Hi there, and welcome to this video where I'm going to demonstrate some of the new features in AutoVectis Discharger. Discharger is the tool in the AutoVectis Suite that you can use to undertake low-resolution, large molecule charge-state deconvolution. Discharger was always good, but over the past few months we've made a series of exciting improvements that have made the performance even better. And so in this video, I want to show off the performance that we now get. To start Discharger from the AutoVectis flash screen, simply click here. And then inside Discharger, the first thing we need to do is to select the file for processing. Discharger can read files of all sorts of formats, including the AutoVectis absorption mode files, MZ5 and MZML files, Bruker.d folders, and the SpectraSwiss H5 format. But in this example, I'll load a spectrum stored in a text file. This tool allows you to extract mass spectra from text files in many different formats. And once the spectrum is loaded, you simply zoom to the region you want to deconvolve, and then hit the green deconvolve button. As you can see, the newly improved Discharger flasher algorithm does an excellent job of producing a clean, deconvolved spectrum. In order to make it easier to confirm the output of Discharger, we've also included the capability to allow you to import the deconvolved spectrum produced by Unidec for the same file and superimpose it in the deconvolved spectrum display. Then we can zoom in to see some more of the details. In this display, the Discharger output is shown in blue and the Unidec output in purple. And as you'd expect, both tools produce broadly similar results. But Discharger is completing two different steps during its processing. The first of these steps is the charge-state deconvolution, and then after that, Discharger uses a wavelet decomposition method to reveal the peaks in the deconvolved spectrum. The benefit that this second stage of processing brings can be highlighted when you're processing a much more difficult input spectrum. So let's look at one of those. This data is in MZ5 format and contains over 1,000 direct infusion mass spectra. But using this tool we can select a range to sum and load for processing. One of the first things you'll spot in this mass spectrum is that the resolution within each charge state is extremely poor. So let's see how well Discharger can cope with this sort of spectrum. Well, as with the first spectrum, we can see that Discharger is producing a clean, deconvolved spectrum. And as before, let's superimpose the Unidec output into the same display. Here, we can begin to see just how well the updated flasher algorithm has performed even for this more difficult data. And if we zoom in further, we can really see the benefit that the decomposition capability brings. This wavelet decomposition step allows us to cleanly extract detectable components from this undifferentiated background. And if we break apart the spectra, it'll be even more clear. Up here, we can see the same data that we were just showing in that deconvolved spectrum, with the deconvolved Unidec spectrum in purple, the raw Discharger spectrum in green, and the decomposed spectrum in black. In the Discharger interface, the user can choose whether or not to show the raw Discharger output. In the previous example, we had it turned off just for simplicity. This lower view shows a zoom in to the main peak cluster. With the three spectra split apart like this, it's much easier to see that the deconvolution part of the Discharger algorithm is producing an output that is broadly similar to that you'd get from Unidec. but the additional decomposition stage is making it much easier to extract the positions and relative intensities of the detectable components. This then makes it much easier to draw confident conclusions about the assignments of these peaks and any measurements of their relative abundance. Within Discharger, there are optional additional advanced peak detection capabilities, but even at this basic stage it will automatically output a comma-separated deconvol peak list intended for rapid review and that can, if desired, be immediately exported into Excel or some other package for onward processing. So, thank you for watching this quick review of some of the benefits that the improved Discharger flasher algorithm brings. Under the covers, what you can't see are all the improvements we've made in the speed of processing and in the fidelity of the final spectrum, and so I hope you'll be interested in trying it out on your own data to see if these benefit your data processing pipeline. Finally, some of the development of this algorithm was supported by the TopSpec grant as part of the European Horizon 2020 programme. And I've added a link to the main TopSpec website, which you can visit if you want to find out any more about this groundbreaking research project and how it intends to revolutionise the analysis of antibodies by mass spectrometry. If you want to know more about Discharger or any of the other tools in the AutoVectis Suite, or to try them out with your own data, either contact me at kilgourlab.com or contact a member of the team at SpectraSwiss.